Welcome to our third video on triangle congruence. This one will cover ASA and AAS, and we're going to dive right in. Angleside angle postulate states that if two angles and the included side, we talked about included angles in the last video, now we're going to use the included side, so hopefully we can reason our way into what that might mean with some pictures. If two angles and the included side of one triangle are congruent to the two corresponding angles and included side of another triangle, then the triangles are congruent. So angle, side, angle stands for the two angles and then the side that's included in between them. So let's take a look at a picture. So if we take a look at this example here, we have two triangles, and if you notice their congruence markers here, angle B is congruent to angle C, angle W is congruent to angle V, and then side BW is congruent to side CV. So if we look at this, we have angle, side, angle, and that side is in between. It's included in those two angles. So, and that's the case on both of them. Angle, side, angle. It's not like the side is over here. The side is included between those two. So my statement down the bottom, I'm just going to match everything up. B goes with C, M goes with R, and W goes with B, and they are congruent by, angle, side, angle. Last, but certainly not least, is angle, angle, side, which states that if two angles and the non-included side, so this is going to be a side that's not included, of one triangle are congruent to two corresponding angles and the non-included side of another triangle, then the two triangles are congruent. So we talked in the last slide about how the side had to be in between. Well, the side having to be in between was if you wanted angle, side, angle. This example is now a non-included side, and that should give us angle, angle, side. So still okay to have that side that's not in between. It's just going to be a different postulate we're going to be using then. So let's take a look. So in this visual example here, we have the two triangles comparing congruency. T is congruent to R, angle X is congruent to angle M, and side UX is congruent to side EM. And if we'll notice here, that side is not in between the angles. It's not in here between those two angles. So it's still going to give us a congruency. It's just not going to be using angle, side, angle. This will give us angle, angle, side. So the T matches with R. Like we said, the U is going to match with the E because they're the ones that aren't marked. So U matches with the E and X matches with an M, and they are congruent by angle, angle, side. This example is a little bit different because we are given words and not a picture. So the first thing I'm going to try to do is use the information to actually draw my two triangles. So it says GU, side GU, is congruent to side NK. So I'm going to draw a line GU, draw a line NK, and know that I need a triangle here, so I'm just going to go ahead and make it a triangle. And so I'm going to go ahead and mark that GU and NK are congruent. Next piece of information says angle G is congruent to angle N. So angle G is congruent to angle N, so I get to mark that congruency. And then these new letters are showing up, S and O, so that's going to tell me that I'm going to label my missing angles in each triangle with an S and an O. It doesn't tell me technically which triangle to put it in. It doesn't really matter, so I want to make it an S and then an O, but those are congruent, so they're going to get marked as congruent also. So now determining whether these triangles are congruent, I'm looking for what relationship they're showing. So I definitely have an angle. I've got two angles, angle, angle, but the side that's congruent is not in between It's the non-included, one of the non-included sides, but it is an angle-angle-side relationship. Angle-angle-side relationship. So they are congruent, and so I'm going to go ahead and write my congruent statement. Triangle GUS is congruent to triangle NKO by angle-angle-side. This next problem is very similar to the last one, so I'm just going to go ahead and work through it without doing any talking. If you need an explanation, please go back to the previous example for that. So I was able to get to here, and then I had to stop. Everything looks good. These triangles are congruent. There are two angles. Oops, I need to add a separate R and M, so there's two marks there. They are congruent by angle, side, angle, because the side is included in between the two angles. The problem is I went to write my congruency statement and realized there's no third letter there, and you can't just say triangle GR and triangle JM. You're going to need something else here, and if that ever comes up for you, you honestly can pick whatever letter you want to pick. I'm just going to pick A and B. So I'm just going to say that triangle GRA is congruent to triangle JMB by angle, side, angle. These next couple problems are going to act as a little bit of review. The goal will be to name another condition necessary to show that they are congruent. Currently, these two triangles do not show enough congruent information in order for them to know that the triangles themselves are actually congruent. So one of our choices when we know that two of the sides are congruent is side, angle, side. We just have to remember which angle we need to pick. And remember, just the way that it is written, that angle needs to be included in between the two sides. So in this triangle here, the FG and the GH are the two sides that are that are part of the congruency, and G is that shared angle. So G is the one that needs to be congruent to, looks like angle J over here, because that is the one that's between the two congruent sides. So we would need, name another necessary, we would need angle G to be congruent to angle J. Same setup here, just now in this case we're looking at the other choices with two sides is to have all three sides congruent, so side to side, side. So in this one, the only side missing is that we need FH to be congruent to PC. So we need FH to be congruent to PC. So that's what we would need to do side, side, side. Same question, different set of triangles here. In this set we have one set of angles and one side that is marked congruent. Whenever we have just one of each, we have a couple different options, side, angle, side, angle, angle, side, angle, side, angle, a couple different choices here. So what we're going to start with first will be angle, angle, side. So remember, the side is going to be the one that's not included, but we've got two angles and then a side. So it looks like for this one, I'm going to make angle D and then angle S and then that side there. I'm not going to do angle A because then that would be angle, side, angle. I'm going to do angle, angle, side in this example. So angle D would be congruent to angle T over here. So angle D would be congruent to angle T, and that would be by angle, angle, side. So that's just one of the choices with this set of triangles. Another option would be side, angle, side. Talked a little bit about that one here. So side, angle, side. I'm going to need, that angle needs to be included. That angle needs to be in between. Remember the nose with the whiskers. So this is the angle that's in between. So I have no choice but to make this SD and this LT be congruent here. So side SD needs to be congruent to side LT. And last option with this set of triangles is angle, side, angle. So we need the side to be included in this one. So the side that's already marked is going to be included. The angle would need to be angle A to angle P. So angle A is congruent to angle P in order for it to be using the angle, side, angle postulate. Last set of triangles here. These triangles, the only piece that are marked congruent are two different angles. So let's see what we can come up with the two different angles that we need to have, which information we would need to actually prove those triangles congruent. Okay, so let's take a look at angle, side, angle option. That side needs to be included. So based on where the congruent angles are located, my only choice is for YQ to be congruent to BC. And notice that when I said YQ, I have to say BC. I cannot say CB because of the way that these are marked congruent. So Y is the one that's congruent to B. So if I'm going to say YQ, then I need to say BC. And that does count towards your correctness. So you want to make sure you're paying attention to your order here. So YC needs to be congruent to BC in order for us to use angle, side, angle. Our other option when we have two of the angles is angle, angle, side. So in this problem, you just want to make sure that the side is not included. And if we look at our triangles, out of the three sides, only one of them is included. So if you're going to use angle, angle, side, there's no wrong answer as far as if you're going to say, okay, I want RY or you want RQ. You just need to pick one and then be consistent with how you're telling me which one it needs to be congruent to. On this one, it has to be the corresponding side. So for example, if I'm going to choose YR, then I need to be choosing BV. So YR needs to be congruent to BV, or I'll use a different color here, or the choice would be RQ would need to be congruent to VC. Those would be your two answer choices, because as long as the side is not included in between the two angles, you can use the angle, angle, side. Make sure that you're using the corresponding sides, however. All right, so here they all are, all four of the postulates. First one in purple here is going to be side, angle, side example. Then we have angle, side, angle example. This is an angle, angle, side, and this one is side, side, side. So use this last slide especially to kind of help summarize everything, pull it all together, and just to see visually what they all look like compared to each other. But these are the four choices we have right now with to prove that two triangles are congruent.